So the word quotient means which operation? Come over here. Huh? Divide, yes. Shh. So the quotient rule applies when you're dividing two functions. Okay? That's how you know when you use it, right? We know to use the product rule when you're multiplying two functions. We use the quotient rule when you're dividing two separate functions. For example, let's say we had f of x equals 3x squared over sine of x. That's not the same as 3x squared times sine of x. It's dividing. So we're going to use the quotient rule. Now again, I'm not expecting you to memorize any of this proof. I have done this before though. If you want to do a proof for me without the notes, I can give you extra credit. I actually have a couple proofs over there on the wall that students have done in the past. But anyways, how can we find the derivative? Well, you can't use the product rule, right? Because, I mean, this is dividing. So here's what we're going to do for our proof. All right, we're going to label our function q of x, meaning the quotient of two different functions. So f of x could be anything. X cubed plus 7, whatever. G of x could be anything. Square root of x, sine of x. By the way, who remembers what the derivative of sine is? Cosine, yes. So that's the only other function we've learned its derivative other than like a polynomial. All right, so going back to the definition of derivative, in this case it's q prime, limit as h approaches 0 of q of x plus h minus q of x over h. All right. We've already defined q of x to be f of x over g of x, so q of x plus h is equal to f of x plus h over g of x plus h. So this is going to be replaced with f of x plus h over g of x plus h, and this is going to be replaced with f of x over g of x. So that's straight substitution. Now what we're going to do, in short, we want to combine these two fractions. In order to do that, they have to have a common denominator. So we're going to multiply the left fraction by the right denominator, and we're going to multiply the right fraction by the left denominator, like that. That way, both denominators are g of x plus h times g of x, and then we can just subtract the numerators. So we can combine them into one fraction with that common denominator. The next step is really hard to explain. I had to look this up. All right, there's no way I would have figured this out. This is kind of like the reverse of multiplying by the conjugate, where the minuses and pluses cancel the two middle terms. Here we are inserting those middle terms. Again, it's hard to explain why. It's just how the proof works. I'm glad somebody else figured it out, not me. But minus f of x g of x plus f of x g of x becomes 0. So basically I'm just inserting that into this expression, and you'll see why in a second. But certainly I'm not changing the value of it. I'm adding two terms that cancel each other out. So there's that. So now we have this. So we're dividing by h. We can tuck that h into the bottom to where it becomes one single fraction, which is what we want, so that we can show this proof. So the next thing to notice or to think about is, what do these have in common? Well, the first two terms have a g of x in common, right? The second two terms have an f of x in common. I'll underline that so you can see. So here's the g of x in the first two terms. The second two terms have an f of x in common. We can pull those both out basically as a GCF. We can pull both of them out, which is what we're going to do. So we're going to pull that g of x out of the first two terms, and we're going to pull that f of x out of the second two. And now we can kind of start to see it begins to look like the definition of the derivative. This looks like the top of the derivative, f of x plus h minus f of x, and this also looks like the top. All right, so the next thing we're going to do, I got to pause this for a second because we're going to pull a negative out of the top. Even though only one term is negative, we're basically going to pull it out. That's going to leave us with negative f of x times negative g of x plus h. So basically all the signs flipped. All right. The next step, again I'm going to have to pause. Then we're going to flip these two, so I'll just draw an arrow here. We're going to reverse those two. So now the g of x plus h goes first, minus g of x. Then we have that. I think the proof is almost done. Okay, so we have f of x plus h minus f of x over here. We have g of x plus h minus g of x over here. So now it's starting to look like the derivative of g, right? And that's what we're going to do. We're going to split this fraction up into two separate fractions. So we're going to take the g of x plus h over g of times g of x and make it a separate fraction right here. And then we have h over here. Now we're going to split up into two separate fractions. This over h becomes one fraction, and this over h becomes the other fraction. Then we're going to pull a g of x out of that one and an f of x out of that one. And now you can kind of see this right here is f prime, and over here is g prime, because it's g of x plus h minus g of x over h. So basically what we have is g f prime minus f g prime, and we'll talk about that in a second. So if we rewrite them in terms of the definition of the derivative, that's what we get, g f prime minus f g prime. Then we can plug in 0 for h. Now the h's cancel. Let's see. I'm trying to figure out where the h's cancel here. Oh, the h's go away because there's the definition of the derivative. Okay. So now we can plug in 0 for h, and we get g of x times g of x, which is just g of x squared. So to complete the proof, we have g f prime minus f g prime over g of x times g of x, which is g squared. And like I said before, I actually like to write the f prime first. So basically we're just going to reverse these two. So f prime becomes first, and the second one's fine. The reason I do that because it basically is like the product rule. The product rule says f prime g plus f g prime. The quotient rule says f prime g minus f g prime. And of course you have the g squared on bottom. So that's the proof. As long as it is, that's how it works. And I just like to write it like this for the quotient rule. F prime g minus f g prime over g squared. There's no sense in writing f of x and g of x because it's the same thing. And this is how you would read it.